Hi, this is John Isles and welcome to Geometer's Paradise. Today we're going to talk about right angle relationships, building off of what we talked about yesterday. Euclid's idea that when you stand a line on another line, then each of the angles is a right angle and the straight line standing on the other is called a perpendicular. We basically learned yesterday that we have a difference between what Euclid was talking about and how we interpret this modern version of perpendicular. Euclid allowed just for segments, but of course we use lines, and lines create four angles, whereas Euclid's definition creates only two. So what that means is we need to figure out if all four of these angles are right angles, or if we're stuck with just the two from Euclid's definition. And what we're going to do now is open up GeoGebra and have a look. Okay, let's draw a new circle. This is going to be used for angle congruence. So make A to be kind of small, and then let's draw a circle around them. Now we're going to draw a line segment, a line, not a line segment, a line that goes from A to B, and then a perpendicular line that goes through A to B. Of course, this is the modern definition for perpendicular. What we're going to do next, though, is to come around this circle, and then I'm going to hide both of the lines. So we plotted 4 points clockwise around the circle. Now we're going to hide both the lines, and I'm going to draw 4 rays. And then I'm going to go back and I'm going to change their colors. So go A to B, A to C, A to D, and A to E. Okay? And now let's change the colors of these rays. So this will be the red ray. And then I'm going to change this one. Oh, yep, there it is. Oh, come on. And it will be the green ray. And then this one over here will be the purple ray. There. Okay. So, Euclid's definition only allows for a line to stand on another line. So the red ray stands on the line DB, which means these two angles are congruent to one another because of the whole perpendicular thing. We can show that very easily with a circle. I'm going to make a red circle here for the red line, go from E to B, and if I put that on E, we see that, hey, yeah, ED and EB, the segments there are congruent, so EAD and EAB are congruent angles. Cool. But then is the purple line perpendicular to EC? This is kind of an interesting question. Is a line perpendicular to a perpendicular to the line? As weird as that sounds. We're going to snag a new compass, click on the arrow, and then click back on the compass so you don't change the color of the circle you've already got. Make it purple. And then we're going to measure D to E. So now I have this new circle for the purple line on EC. And look at there. Alright, we have two congruent segments, which means we have two congruent angles. So EAD is congruent to CAD. Alright, that actually means that these two angles are right angles. We already knew that these two angles were right angles. So the question remains, is this one a right angle? And if I grab my compass, and I come down here and I draw a green circle from C to D, then oh, there it is. Okay, so now these two segments here are congruent because they're radii of the green circle. So DAC and BAC are congruent angles. The last one is not necessary to show, but I'll just toss the circle on there anyway. If I take a blue circle and I go from B to C, then there it is. And of course, EB and BC are congruent to one another. Alright, so what we have here are four right angles, which we know are also congruent because of the transitive property. You have BAE congruent to EAD, EAD congruent to CAD, CAD congruent to BAC, and BAC congruent to EAB again. So they're all chained together using the transitive property. And what this is going to allow us to do is to establish four right angles from the intersection of two lines. And in fact, we're allowed to create 1, 2, or 4 right angles whenever we make a picture. For example, let's draw again here a line segment, and I'm going to gray it out. Okay, so here's our first line segment, AB. I'm going to drop a circle on top of A here real quick so that I get a better picture of where C is going to be. Alright, and there it is. So now I have these two line segments, or these two lines, I'm sorry, AB and CA, and I'm going to go clockwise around the circle and drop points. Okay, now select your ray tool, and let's make it a nice dark line. If I connect A to B and then A to C, I produce one right angle. If I extend AB to infinity in the other direction by connecting A to D, I now have two right angles. And if I extend CA to infinity through E, I now have four right angles. So in the modern definition of perpendicular, we can get 1, 2, or 4 right angles, as opposed to Euclid's definition, which produces 2.